Hello dear students, welcome back to my lesson. Today's lesson we're going to explain transformer. What is transformer? Transformer is a device that increases or decreases the potential difference of an alternating circuit. It means that the transformer can control the magnitude of the output potential difference. So the transformer has many applications in our daily life. For example, some electrical devices require a small amount of potential difference, such as a smartphone. Your smartphone requires only 5 volts. Otherwise, some electrical devices requires more potential difference, more output potential difference, such as a microwave oven. Microwave oven, at least, they require 2000 volt output potential difference. So our outlet potential difference at our home or at a factory is 240 volt. So in this case, we have to use the transformer to changing the output potential difference from 240 volt to 5 volt for charging smartphone, or 240 volt from our outlet potential difference to 2000 volt potential difference to working microwave oven. So that is why the transformer is very important in our daily life. And the simplest transformer consists of what? Consists of primary coil. The wire is wound around the primary coil, and secondary coil with iron core. Okay, the simplest transformer consists of 3 components: primary coil that connected with the input AC source, secondary coil that can be connected with the resistors or device, and the magnetic core, iron core. This iron core guides or traps the magnetic field, guides the magnetic field from primary coil to the secondary coil. Okay, so at first we have to connect the primary coil with the AC source, because transformer would work only with AC source or DC pulsating source. The transformer can never work with DC battery. Why? Because in DC battery, the amount of current does not change. Okay? If the amount of the current or its direction does not change, there is no change in magnetic flux here. And there is no induced EMF and induced the current in the secondary coil. So that is why we need what? AC source or DC pulsating current. When we input, for example, if I run a current from this AC source to the primary coil, the current passes through this coil, and because the magnitude and direction of the current from AC source changes continuously, that is why the change in magnetic field will exist in the primary coil. When the magnetic field changes, the magnetic flux also changes. Okay, so this magnetic field line is from primary coil, it goes to secondary coil. By what? By the iron core. So what is the function of iron core? Guides or traps the magnetic field lines from primary coil to the secondary coil. So this equation can be used for the transformer to calculate the input potential difference or output potential difference. Okay, so in transformer we have 2 coil, primary coil N1 and secondary coil N2. So we have 2 types of transformer: step up transformer and step down transformer. I will explain in detail. Okay, but at first I would like to prove this equation. Okay, so this equation came from the Faraday's equation. According this equation, potential difference across the input source is equal to negative N1 change flux per unit of time. Okay, so if you rearrange this equation, if you take N1 to the other side, it becomes E1 over N1 equal to negative change flux per unit of time. This is for primary coil. For what? For primary coil. In the secondary coil, E2 is equal to negative N2 change flux per unit of time. If you rearrange the equation, E2 over N1 is equal to negative flux per unit of time. Okay? If you see that these two sides of these two equations are equal, these two sides are equal, and also these two sides becomes equal. Okay? So that is why E1 over N1 is equal to E2 over N2. Okay? E1 over N1 is equal to E2 over N2. And you can write V1 instead of epsilon, V1 over N1, because they have the same meaning. V2 over N2. What is V1? The potential difference in the input side, in a primary circuit, potential difference in primary circuit. N1, number of turn in primary coil. V2, the output potential difference in a secondary coil, in a resistance. N2, number of turn in secondary coil. Okay, so we have two types of transformer. The types of transformer, we have two types of transformer. Step up transformer and step down transformer. Step up and step down. In step up transformer, N2 bigger than N1. So the output potential difference also bigger than the input potential difference, such as the microwave oven can be working by using the step up transformer, because you know that our outlet potential difference at home is 240 volt, but the microwave oven requires 2000 volt. So in that case, we have to use step up transformer. So in step down transformer, N2 less than N1 and V2 less than V1. Okay, such as smartphone mobile requires only 4 volt or 5 volt. So in this case, we have to use the step down transformer from 240 volt to 5 or 4 volts. So this is generally about the transformer. Okay. Okay. This is the definition of transformer: device that increases or decreases the EMF of alternating current. So when the potential difference changes according to Ohm's law, the current also changes. Okay? But in transformer, the current is also increases and decreases by increasing and decreasing the potential difference. In its simplest form of transformer, an AC transformer consists of two coils, primary coil and secondary coil, okay, around a core of soft iron, like the apparatus of the Faraday experiment. AC current and DC pulsating current would work with transformer. It means that the transformer can be working only with AC current and DC pulsating current. Why? Because in both types of the current, the magnitude of the current changes. But in the case when the magnitude of the current does not change, its direction does not change, so there is no magnetic flux will be changed in the primary coil and in the secondary coil. Okay. So why the DC current? When we say DC current, it means that the DC current of battery would not work with the transformer, because the reason is that changing current is required for what? for the changing magnetic flux in the primary coil to the secondary coil, because in the secondary coil, the potential difference, the induced potential difference in the secondary coil depends on the change in magnetic flux. When there is no change in magnetic flux, there is no potential difference induced in the output circuit. Okay? What is the main components of the transformer, or what are the main components of the transformer? We have three main components: primary coil, secondary coil, and iron core. Okay, primary coil has N1 and secondary coil has N2 and iron core. What is the uses of the iron core, or what is the advantage of the iron core? The iron core guides or traps the magnetic field lines, so that nearly all of the field lines passes through both coils. Look at this. This is iron core. Okay, this iron core guides the magnetic field lines from primary coil to the secondary coil. As you know, in AC current, because the magnitude and direction of the current changes, it means that there is a change in magnetic field. When the magnetic field changes, the magnetic flux also changes. So it means that the input potential difference per unit of number of turn depends on what? Depends on the change of the magnetic flux. So this changing in magnetic field, it passes through the iron core from primary coil to the secondary coil, and from secondary coil to the primary coil. Okay. So how electrical energy is in transformer from primary coil to secondary coil? Electrical transformer, this magnetic field lines, as I told you, passes from primary to the secondary coil, and in the secondary coil, the potential difference is induced. Sometimes this potential difference is increased, step up, and sometimes this output potential difference is lowered, step down. So the rules of transformer is N1 V2 is equal to N2 V1. So I proved this equation. Also, you can write down like that and like that. Okay. So we proved this equation. Okay. V2 is the induced EMF in the secondary coil. V1 is the potential difference in primary coil. So we have this term N2 over N1 is called conversion ratio. What is conversion ratio? Is the number of turn in secondary coil to the number of turn in primary coil. This term is called what? Conversion ratio of transformer. And also is equal to V2 over V1, because N1 over N2 is equal to V1 over V2. Look, what is conversion ratio N2 over N1? If the question says find conversion ratio, you have to find number of turn in secondary coil to the number of turn in primary coil, which means that N2 over N1 or V2 over V1 is the ratio between the number of turn in secondary coil to the number of turn in primary coil. What is the difference between step up and step down transformer? In step up transformer, N2 bigger than N1. Okay, so V2 also bigger than V1, sorry. N2 over N1 should be bigger than 1. It means that the conversion ratio must be greater than 1. For what? For step up transformer. Okay, the conversion ratio should be bigger than 1. For what? For step up transformer. And V2 over V1 also bigger than 1. But I2, sorry, this is I1, this is I2. Okay, but I1 should be less than, sorry. In step up transformer, I1 bigger than I2. Okay, it's opposite to the potential difference. So which means that I2 over I1 less than 1. In step up transformer. In step up transformer converts what? Low current or low potential difference to the high potential difference. Low voltage to high voltage, and converts high current to what? To the low current, because the power is unchanged. That is why P is equal to IV. Okay, there is inversely changing between the potential difference and the current. In the case when potential difference increases or step up, the current should be decreased. Why? To remain the power unchanged. The power remain constant. In typical transformer, the power remain constant, so there is a change between the potential difference and current. In step-up transformer, potential difference rises, but it is current, it decreases, lower it. Okay, so that is why there is inversely change between potential difference and the current. In step-down transformer, N2 less than N1, V2 less than V1, N2 over N1 conversion ratio less than 1, for potential difference also less than 1. This is wrong. Okay, I1 bigger than I2 bigger than I1. Okay, so I2 over I1 bigger than 1 also. Okay, converts high voltage to the low voltage and convert low current to high current. Power stay unchanged for an idle transformer. In an idle transformer, the power does not change. Okay. An increase in induced EMF at the secondary coil V2 means that there must be a proportional decreases in what? In current. Why? Because power in idle transformer is constant, is equal to I times V. When power is constant, by decreasing potential difference, the current increases. By increasing potential difference, the current decreases to remain the power constant. Okay. In reality, the output power will be less than the input power because energy is lost to what? To heating and radiation. When the current in idle transformer, there is some losing of electrical energy or some of the electrical energy is converted to heat. But in ideal transformer, there is no losing of the power. Okay? But in reality, there is no transformer, there is no an idle transformer in reality. Okay? When the current runs from the primary coil, this current passes or runs through this coil, some of this electrical energy is converted to the heat. Why? Because this coil has its resistance. The coil is not pure. Okay? So that is why the input power is always bigger than the output power. Why? Because in the output power, the current dissipated, the power dissipated in primary coil and secondary coil. Okay? So that is why P input is bigger than P output. Why? Because in the output potential difference, some of the electrical energy converted to heat. From where? From primary coil and secondary coil. Some of the electrical energy is converted to heat from primary coil and some of the electrical energy converted to heat in secondary coil. So that is why the input power is always bigger than the output power. In what? In real transformer. But in an idle transformer, there is no losing of power, so that is why input power is equal to output power. Okay? But in an idle transformer, P input is equal to P output. So the flux through the multiple loops is equal to the flux through one loop times the number of the loops. So that is why in step-up transformer, number of turn in secondary coil should be bigger than number of turn in primary coil. Why? Because more number of turn produces more induced EMF and induced current, because it is directly proportional. Okay? So the students should keep in mind that the number of turn in coil and EMF are directly proportional. More number of turn, more induced EMF. If number of turn in the secondary coil is greater than in the primary, which means that N2 bigger than N1, the induced EMF will be greater. V2 also will be greater than V1. Okay? When does the transformer become step up and step down? When the conversion ratio is bigger than 1, step up, and when the conversion ratio is less than 1 is step down. So I'm going to repeat this note. It's very important. The transformer cannot work with DC battery. Why? Because in DC battery, flux per unit of time 0. That is why EMF in the secondary coil also 0. While it works with what? Transformer works with what? AC current or DC pulsating current. Okay? Why? Because in DC pulsating current, the magnitude of the current change that require for magnetic flux to be occur. In AC, both magnitude and direction changes. Okay? So what is the difference between step up? Yeah, we explain it. This is question 19 from chapter review. We studied. Okay? Question 20 from chapter review. Does step up transformer increase power? Explain your answer. No, the step up transformer does not cause to increasing the power, because power is equal to what? Is equal to IV. In step up transformer, what happened to the potential difference? Increases. What about the current? Decrease. But power remain constant. Power remain constant, because according to this equation, there is an inversely changing between the potential difference and the current. No, the step-up transformer cannot cause to increasing the power. The change in potential difference in transformer is accompanied by what? By an inverse change in what? In current. What do you mean by an inverse change in current? It means that when potential difference increases, the current decreases. Okay? In an idle transformer, power is unchanged as expected from the energy conservation. Okay? But in real transformers, some of this power is lost to heat. In many transformers, the wire is around one winding is thicker and therefore has a lower resistance than the wire around the other winding, which means that if I draw the figure for this question, if you have a transformer and winding with a thick wire, okay, and okay, the output okay, this is V2 and this is V1. So we have the same number of turns in both coils, in both primary and secondary coils. But what is the difference between these two coils? The primary coil, the wire that wound around the primary coil is thicker than the wire that wound around the secondary coil. So can you determine the type of the transformer by thickness and the thinness of the wire from primary and secondary? Actually, yes, you can do it. You can find it because the thick wire has low resistance. Thick wire has what? Has low resistance. Okay, so the resistance V is equal to what? Is equal to IR. Okay, and when the resistance is lowered, okay, it means that the magnitude of the current increases. Okay, the current, the more current passes through the coil. Okay, but in this book, according to the last update in this book, this question should be answered by that. No, you cannot find the types of the transformer by the thickness and the thinness of the wire. But actually, you can find it. Why? Because there is a change in the current between the primary and the secondary coil. When the current changes, the potential difference also changes. According to the equation, power is equal to IV. Okay? So that is why the types of the transformer cannot be determined by the thickness and the thinness of the wire, because the type of the transformer depends on the ratio or conversion ratio between the number of turns. If conversion ratio is bigger than 1, this type of transformer is step up. If conversion ratio is less than 1, this type of transformer is step down. Okay, so it means that this question has two answers. The second answer, according to the last update of the book, is correct. Okay, so the step up transformer for voltage potential will be step down for the current. Yes, according to this equation, at constant power, potential difference varies inversely with the current. Okay. Question 25. Would a transformer work with pulsating directed current? Pulsating directed current. The transformer would work with pulsating directed current? Yes. Why? Because there is change in magnetic flux per unit of time. Yes, because the current changes continuously. So it is changing magnetic field can induce an EMF transfer in secondary coil. But with DC battery, the transformer does not work. So I summarize it between the step up transformer and step down transformer. You can get some advantage from this table. Okay. Let's solve the questions and the sample problem which related with the transformer. It is easy, just plug in into the equation. A step-up transformer is used on a 120 volt line to provide a potential difference of 2400 volt. So what is the type of the transformer? Step up. So it means that V2 should be greater than V1. V2 was given 2400 volt. V1 also was given 120 volt. Okay. If primary has 75 turns, primary N1, 75 turns, how many turns must the secondary have? N2 is unknown. It is too easy. N1 over N2 is equal to V1 over V2. To find and to rearrange the equation, N1, V2, we have N1, 75, V2, 2400 divided by 120. N2 must be bigger than N1 and is equal to 1500 turns. This is sample problem 6H. Practice 6H, a step-up transformer. Question number 1, also step-up transformer. Used in automobile has a potential difference across the primary, which means that V1, 12 volt, and potential difference across the secondary, V2, 2 times 10 power 4 volt. If the number of turns in the primary, 21. What is the number of turns in secondary? The same equation of a previous question can be used to calculate number of turns in the secondary coil. Okay, thanks for listening. Inshallah, in the next lesson, we will continue and we will solve all questions that are related with the transformer.